Okay, so as in last video we have derived the formula for finding the velocity of the mass spring system or velocity of motion under elastic restoring force, which came out to be v is equal to under root k over m into under root x naught square minus x square. How we derived this formula? We just took our initial formula of velocity, which we actually found for the projection of a particle along uniform circular path, which was equal to omega under root x naught square minus x square. Then in the last video we found the formula for finding the omega, right? So omega is equal to under root k over m. We just substituted the value of omega in this formula, and we actually got the final formula for finding the velocity of the motion under elastic restoring force or Hooke's law, or you can say mass spring system, which is equal to under root k over m into under root x naught square minus x square, where k is the spring's constant, m is the mass of the body, x naught is the maximum displacement, or you can say amplitude, right, which in the projection of a particle along uniform circular path was equal to r, radius of the circle. But here we cannot actually say x naught is the radius, since we are not talking about here circle, we are talking about here mass spring system. So this x naught is actually amplitude. And what is amplitude? It is the maximum displacement from the mean position to the extreme position, and x is simple displacement, right, from any point where you can consider. So what we are going to do today is we are going to find the maximum velocity. What is the formula for finding the maximum velocity, and what's the formula for finding the minimum velocity? We are just going to derive these two formulas today. We are already known, right, where we're going to have our maximum velocity, where we're going to have our minimum velocity. So initially we must say where we're going to have our maximum displacement, where we're going to have our minimum displacement, right? So what we are going to do today is we are going to find the maximum and minimum velocity. Here we're going to have our maximum velocity, and here we're going to have our minimum velocity. All right. Initially maximum velocity, and here we're going to have our minimum velocity. Minimum velocity, right? Now see, here at mean position we're gonna have our maximum displacement. See where we're gonna have our maximum velocity. We're gonna have our maximum velocity at mean position initially. At mean position we're gonna have our maximum velocity, and minimum velocity we're gonna find at extreme position. At extreme position, minimum velocity at extreme position, maximum velocity at mean position, right? At mean position we know that at mean position our displacement is 0, since displacement is always taken away from the mean position. So at mean position our displacement is 0, which is denoted with x is equal to 0, right? Now see, let's write the formula for finding the velocity again. What we have the formula for finding the velocity of a particle, or velocity of the motion under elastic restoring force, Hooke's law, or mass spring system. V is equal to under root k over m into under root x naught square minus x square. This is the formula for finding the velocity, right? Velocity of the mass spring system. Now see, we have put our x equals to 0. our x equals to 0, which means our displacement is 0 at the mean position. So let's substitute the value of it. V is equal to under root k over m under root x naught square minus, instead of x square we write 0 square, right? So what's the final formula for finding the maximum velocity which you're gonna have at your mean position, since your displacement is 0 at mean position, is v is equal to under root k over m into under root x naught square. See, this square cancelled with this under root, right? Wait for it. So what we're gonna have our final formula, v is equal to x naught under root k over m. Under root k over m. This is the final formula for finding the maximum displacement which we're gonna find at mean position, right? V is equal to x naught. X naught is the maximum displacement from the mean position to the extreme position, under root k over m, right? Now see, you're gonna have your minimum velocity at extreme position, right? Let's write again. Here we're gonna have our displacement, x would be equal to x naught, which you can actually say amplitude, right? Amplitude. Here you will have your maximum displacement. At extreme position you're gonna have your maximum displacement and minimum velocity and maximum acceleration too, right? So here you're gonna have your maximum displacement, which means your x is equal to x naught. X naught is the maximum displacement from the mean position to the extreme position. Let's substitute this value in this formula. In the formula v is equal to under root k over m into under root x naught square minus x square. So let's substitute the value of x, which is x naught. So v is equal to under root k over m into x naught square, and the value of x is x naught, again x naught square. X naught square minus x naught square is actually equal to 0. So k over m into 0, where the entire factor equals to 0, and this is what we found our minimum velocity. So our minimum velocity is always equal to 0, and our maximum velocity is x naught into under root k over m. So today we have found our maximum and minimum velocity of the motion under elastic restoring force, or Hooke's law, or mass spring system as well. In the next video we're going to drive the formula for finding the energy of the mass spring system, kinetic energy, potential energy, and the total energy. This was all for today.